Hello viewers, welcome to my channel. I'm Hasham. Now I'm starting unit number 2 in the subject statistics for management. Already first unit I have completed where different topics we have completed like measure of central tendency, measure of dispersion, measure of skewness, and next we have discussed about probability theory, Bayes theorem. These are all the topics we have covered in unit number 1. Now in unit number 2, the topic is probability distribution, theoretical distribution. What do you mean by theoretical distribution? What is random value? What is expected value? Expected variable of random value. And then I'm going to explain you about the binomial distribution in this video. After doing this, next video will start the problems on binomial distribution. After that, we'll discuss about Poisson distribution and normal distribution. So if you want the perfect knowledge, watch all the videos from beginning till end. Don't skip in between. If you have not watched the earlier videos, I suggest you go to the playlist of my channel. Select the subject statistics for management. Watch all the videos. Be perfect. Be confident on the subject. Now before starting this unit number 2, take the screenshot of the points which I have written on the board. Then I'll explain every point in detail. Now first of all, probability distribution. Actually, frequency distribution can be classified into two categories. That is observed frequency distribution and expected frequency distribution. So all the frequency distributions can be divided into observed and theoretical or expected. So what is this observed frequency distribution? When actually we collect the data by observation, by experimentation, we are collecting the data and making a distribution. That is called observed frequency distribution. So most of the times we collect the data on the field. We collect and make the experiment, observe and make the distribution. Example, simple example. In a class, so many students are there. The marks obtained by all the students in the class can be classified in a frequency distribution. That means how many students are there who got the marks from 0 to 10, 10 to 20, 20 to 30. Like that we can classify the marks obtained by different students in a class. So by observation we are collecting the data and making the distribution. That is called observed frequency distribution. Apart from this observed frequency distribution, we can make a frequency distribution based on some theory, based on some experience, past experience. So according to some theory, according to past experience, mathematically we can deduce the frequencies. The frequencies we are not actually collecting, but we are finding out theoretical values of the frequencies and making the distribution. So any frequency distribution in which the frequencies are mathematically deduced or theoretically calculated, not actually, theoretically calculated. So those type of distribution are called theoretical distribution or probability distribution. Such distribution are expected on the basis of previous experience or theoretically consideration, known as theoretical distribution or probability distribution. So I have explained you the meaning of observed frequency distribution and expected frequency distribution. Now probability distributions are again classified into two categories. That is discrete probability distribution and continuous probability distribution. So what is this discrete? A discrete probability distribution is allowed to take only limited number of values. That means when we take only integers, when the random variable takes only the whole numbers, not fractions. Just like x, the random variable may be 1, 2, 3, 4 like that. So we are taking any whole number 1, 2, 3, 4. There we apply discrete probability distribution. only limited values we are going to take. Whereas in continuous probability distribution, on the other hand, the variable under consideration is allowed to take any value under a given range. That means even the whole numbers or fractions are there that will be taken in continuous distribution. A range of values. For example, the marks from 0 to 10. So any marks, whether it is a whole number or fraction, anything can come. So if the random variable are only whole numbers, we have to apply discrete probability distribution. If the random variable can take any value, whole number or fraction, we have to take the continuous frequency distribution. Now, next concept which may be asked in examination is, what is random variable? What is expected value of random variable? So first of all, random variable. A variable which assumes different numerical values as a result of random experiment is known as random variable. So any variable which can take different values, any variable which can take different values depending on different experiments. So by conducting different experiments, the value will change. That value is called a random value. So it is a variable which have different values depending on different experiments. So a random variable experiment is known as random. A random variable is a variable that takes on different values as a result of outcome of random experiment. As a result of random experiment, you will get different values. That is called random variable. So a random variable can be either discrete or continuous. Either it may be a whole number or it may be a fraction or whole number, anything. That is called random variable. Now what is expected value of random variable? If we assign the probabilities to the random variable and multiply the probability with random variable and sum up, you will get the expected value of random variable. So expected value of random variable is simply the mean of the random variable, the weighted average of the random variable, where weights are the probabilities. Example, the random variables are 5, 10, 15, 20. These are the random variables. And the probabilities are assigned to each of the random variable. The probabilities are 0.4, 0.3, 0.2, 0.1 like that. The probabilities are given, random variables are given. Now multiply the random variable with probability and add up all. You will get expected value of random variable. So for taking decisions under conditions of uncertainty, the concept of expected value of random variable is used. So normally this expected value of random variable will be used whenever we take the decisions under the conditions of uncertainty. We are not sure, we are not certain in that uncertain situation how to find out the value. So this expected value of random variable is very much helpful. So the expected value is the mean of the probability distribution. Actually arithmetic mean, weighted mean. The mean is computed as the weighted average of the value of the random variable and can assume the probability assigned are used as weights. See here, this expected value of random variable is the weighted average of the random variables. In this weighted average, the weights are nothing but the probabilities. And the probability assigns are used as weights. The expected value of random variable is computed by summing up the random variables multiplied by the respective probabilities. Just now I told you, we are given the random variables, we are given the probabilities, multiply the probability with random variable and take the total, sum up. This will give you expected value of random variable. Now, the following are the most commonly used theoretical distribution. There are many probability distributions, but the most commonly used theoretical distribution or probability distribution are binomial distribution, Poisson distribution, and normal distribution. These three types of distributions are widely used in practice. So in this video, I am going to explain you only about binomial distribution. Then after completing the problems on binomial distribution, we'll come over to the next probability, that is Poisson, and then normal. Now, binomial distribution. So binomial distribution is also known as Bernoulli process. because the name was given to the Swiss mathematician, that is James Bernoulli. In Switzerland, the mathematician James Bernoulli, he has propounded the theory of this binomial distribution. So Swiss mathematician James Bernoulli, binomial distribution is a probability distribution expressing the probability of one set of dichotomous alternatives, that is success or failure. That means in any experiment, if there are only two outcomes, that's why it is called dichotomous. Dichotomous means two. In any experiment, if we are getting two outcomes, success and failure, in that conditions only we can apply Bernoulli process or binomial distribution. So simply, binomial distribution is a frequency distribution which can be applied only when in an experiment only two outcomes will be there, success or failure. Then it is very widely used probability distribution or discrete varying. Remember, this binomial distribution can be applied only for discrete values, not for continuous values. Now, the tossing of a fair coin a fixed number of times is a Bernoulli process, and the outcome of such tosses can be represented by a binomial distribution. Simple example, tossing of a coin. When a coin is tossed, only two outcomes will be there, head or tail. Head or tail, only two outcomes. So if this coin is tossed for a number of times, finite number of times, we can apply this binomial distribution. Now, the mathematical model of Bernoulli process is developed under a very specific set of assumptions. Actually, James Bernoulli, he has given that this binomial distribution can be applied only when a set of assumptions are satisfied. If the assumptions are not satisfied, we cannot be able to apply binomial distribution. So what are the set of assumptions? Remember, in examination you may get a theory question regarding explain about binomial distribution and what are the assumptions for applying this binomial distribution. So this theory which I am going to explain you is not only important for problems, but also you may get a theory question. So watch it with full concentration. Now, first assumption. An experiment is performed under the same condition for a fixed number of trials, say n. That means the experiment on which this binomial distribution is being applied should be under the same conditions. The conditions of making the experiment should not change, because we are making a trials of the experiment. First trial, second trial, third trial, finite number of trials we are making. So the conditions of making these trials should not change. Same conditions should be there by one trial to another trial. So a finite number, n number of trials we are applying. Second, in each trial there are only two possible outcomes, success and failure. If we are getting three or more than three outcomes, we cannot apply binomial. So binomial distribution requires that only two outcomes should be there in the experiment, in the trial, success or failure. The probability of success denoted by small p remains constant from trial to trial. The probability of success will be denoted by small p, and the value of small p should remain constant from one trial to another trial. Simple example, when you throw the coin, the probability of head is 1 by 2 and the probability of tail is 1 by 2. So when you throw the coin first time, the probability is remaining 1 by 2. Second time if you throw, again it will be 1 by 2. Third time if you throw, again it will be 1 by 2. That means the value of p should remain constant from one trial to another trial. The probability of failure denoted by q is equal to 1 minus p. Only two outcomes are there, for success or failure. The success we are denoting by small p and failure we are denoting by small q. And if we are having p value, automatically we can get the q value, because q is equal to 1 minus p. Suppose the probability is 1 by 3. 1 by 3 is the probability of success, p. So q is equal to 1 minus 1 by 3. 1 minus 1 by 3 is 2 by 3. So if we are having the value of P, easily we can get the value of Q, because Q is equal to 1 minus P. If the probability of success is not same in each trial, we will not have binomial distribution. Main condition is the value of P should remain constant from one trial to another trial. If the probability of success will change from trial to trial, then binomial distribution cannot be applied. That is the condition. Last one, the trials are independent, that is the outcome of any trial will not be affected by the outcome of the subsequent trials. Every trial should be independent. That means the outcome of one trial should not have any effect on the outcome of the subsequent trials, because every trial will be different, independent, not related with the previous trials. So these are the set of assumptions. If these assumptions are satisfied, then only we can apply binomial distribution, right? Now, it is the most fundamental and important discrete probability distribution in statistics and is defined by the probability function. So this binomial distribution is very important probability distribution, which is widely used in practice. And the probability function is denoted by P of R is equal to NCR P to the power of R Q to the power of N minus R. This is the formula for calculating the probability of R successes. Probability of R successes in N trials. N, small n, how many trials we are making. So what is the probability of R successes in N trials? For example, a coin is thrown for 10 times. What is the probability that we will get 4 times head up? So our success is getting head up. So we want 4 times head up. What is the probability that out of 10 times we will get 4 times head up? So in this type of situation, we apply this function. P of R is equal to NCR P to the power of R Q to the power of N minus R. Now, which gives the probability of R successes in a series of N trials. So this formula will give you what is the probability of R successes in N trials. The two independent constants, that is N and P, are called the parameters of binomial distribution. For applying the binomial distribution, the main parameters are two constants. The two constants are N and P. If we have small n, that means number of trials, and P, the probability of success, easily we can find out P of R. We can find out the probability of R successes. Only the thing we need two, N and P. Characteristics of binomial distribution. Again, in examination, theory question will be asked, what are the characteristics of binomial distribution? The first characteristic, binomial distribution is a discrete probability distribution in which the random variable x assumes any value 1, 2, 3, 4 up to n. That means, first characteristic of binomial distribution is it is a discrete probability distribution. That means the random variable will take only whole numbers 1, 2, 3, 4. We cannot apply when the random variable is 1.5 or 1.8 or 1.9. Fractional values we cannot apply binomial distribution, only whole numbers. That's why binomial distribution is called discrete probability distribution. Secondly, the mean. The mean in binomial distribution is n into p, small n into small p. So when you multiply n and p, what you get? The mean of the binomial distribution. Variance. Variance means standard deviation square. Standard deviation square is called variance. So how to find out variance? NPQ. Multiply NPQ will get the variance. Now if you want the standard deviation, variance under root. Root of variance will give you standard deviation. The NPQ under root will give you standard deviation. So if n independent, small n, if n independent trials are repeated n times, then the expected frequency of R successes is capital N into small n, NCR, P to the power of R, q to the power of n minus r. See here, if we are required to find out not only probability but also expected frequency. So if you want expected frequency, multiply capital N into P of R. P of R means NCRP to the power of R, Q to the power of N minus R. This is P of R. So multiply P of R with capital N, we will get the expected frequency. That's all. So in this video, I have explained you about the distribution, frequency distribution, observed and expected. What is random variable, what is expected value of random variable, and what are the different types of frequency distributions that I like, binomial, Poisson and normal. But only binomial I have explained. In the next video, we will solve the problems on binomial. After that, we'll discuss about Poisson and normal distribution. So if you are satisfied with my lecture, give a like to the video. Share my channel among your group, among your friend circle, so that more students can watch the video and enhance the knowledge. And give your comments on these videos. Subscribe if you have not yet subscribed my channel. And by the super thanks which is given below my video. Inshallah, we'll continue the problems on binomial distribution in the next video.